So this means ultimately when we test the data plane, it's not going to work because there's that problem for XR3 forwarding the traffic out that particular link. But what we should see now is that when we do a ping or we do a trace route, that we should get at least a little bit further into the network, depending on which direction that we're coming from. So if we look at this from router 3's point of view and do the trace route, well, we can't really tell from this where it is getting dropped. But if we did a packet capture, we would see it would go a couple hops further into the network. But the workaround, again, we need to do on XR is we need to say, globally, if we go under router static, address family IPv4 unicast, we need a static route for 10.3.13.3/32. And this is located out interface gig 0000.313. Okay, if we now look at the show MPLS forwarding table for that address, we now see that there's a POP label. And again, the problem is that the next hop of the BGP route has to be you have to have a /32 label for it in order to do label switching towards the destination. So just like we talked about in IGB before, that if you advertise your loopback and it's not /32, even though you learn the route in the control plane, you can't do label switching in the data plane. It is a requirement that the next hop has to be /32. Okay, so now let's look at this end to end. If we go to router 8, okay, so let's test from 8 to router 10 this is. We're pinging 10, 10, 10, 10. Okay, now we have reachability. Okay, same should be true if we go from 4 to 7. And the key point of this is that once we have reachability, we want to know specifically what is the label switch path that we're using end to end. So what we should see here is that from router 4's perspective, it is learning the route from IGP as it comes in from the PE router. So this is going to be, in this case, from OSPF. XR1 is learning this from VPN v4 BGP from router 1. But the next hop of the route, and in this case specifically the route is 7777, the next hop of the route is 3's loopback. Because 7 is advertising the route to 3 with OSPF. Router 3 is redistributing it into VPN v4 BGP over to router 1. Router 1 is reflecting the route over to XR1, but it said the next hop was what? It was unchanged. So from XR1's point of view, it says next hop is router 3's loopback. So next it says, how do I know this in the global table? I know it from ISIS because we did redistribution of BGP into ISIS on XR1. And since we're running IGP plus LDP in the core between XR1, 2, and 3, on XR1, if we look at now the show MPLS forwarding table, we should see that we have a label value associated with 3's loopback. So it means that we're going to label switch the traffic over to XR3. We're going to be using our IGP plus LDP label. XR3 is going to say, I know the route through BGP, so I'm using my BGP plus label to get to router 3, and then router 3 is the final PE destination, is going to decapsulate the packet and then send it towards 7. So if we do a trace from 4 to 7, what we should see here is that we're going to use the same VPN label end to end, because the VPN label was the one that was originally allocated by router 3. And this is one of the key changes in option C versus option B. In option B, we saw that there were 3 LSPs total. One within the AS up to the ASBR, a second one between the ASBRs, and then the third one in the remote AS from the ASBR to the final destination PE. But in this case, since we're learning the original advertisement that came from router 3 to begin with, we're using whatever label number that it allocated. Okay, likewise, if we go to router 8 and we do a trace to 10.10.10.10, we should see that we're using whatever the same VPN label is end-to-end, which in this case is 19. Okay, likewise, if we were to go to router 10, let's do a trace to 8888. We can see whatever the VPN label is, it's the one that was originally allocated by XR1, which is 16,006 in this case. Okay, then lastly, same should be true when we're tracing from 7. So if we trace to 4444, we're using label 16,000. So again, the other change here that I had made was from router 1 as we're going on the VPN v4 session to the other end, I said leave the next hop alone, have it unchanged as we go to the remote eBGP peer. So let's look at what happens when we don't say that. So from router 1, let's show run section BGP, and we're going to remove this statement here. Okay, neighbor 11.11.11, next hop unchanged. So no neighbor, next hop unchanged. And then we'll clear BGP, VPN v4, unicast star out. Okay, and we're looking at this from the final customer's point of view. How does this affect the traffic flow? So if we look at this from router 4 was previously saying to get from 4 to 7, we were going 11, 12, 13, 3, and 7. So we were basically going whatever the shortest path to the destination PE was. So it was 4 to 11 to 12, 13, router 3, and then 7. Okay, now that router 1 is changing the next hop, this is where we have the inefficiency in the data plane. So the idea is that with the route reflector saying the next hop is me, it's 1111, XR1 says I need to get on a label switch path that goes to router 1. And notice if we look at the transport label goes to 1, then 1 is re-encapsulating it in a new transport label. So it's a 1 label stack when it gets to 1. 1 is reimposing another label and then sending the traffic back to router 2. So it's going 3, 2, 1, 2, 3. It's basically a loop in the data plane, but it's not an infinite loop. So typically you would not want to do it this way. You want to say next hop unchanged so that the route reflector is not in the data plane, and then it's going to remove whatever those additional hops are that aren't needed in the remote autonomous system. So let's say on router 1 that we go back to what we had before, which was the next hop is unchanged. Okay, we then clear BGP, VPN v4, star out, and trace from 4 to the destination. We should see that we don't have those extra hops. Okay, now let's do the same thing on XR1. If we show run router BGP, we're going to say that for the neighbor 1111, we don't have the next hop unchanged. So basically, this is the default behavior of taking an iBGP route and then advertising it to an eBGP neighbor. Again, let's look at how does this affect the data plane. So we're going to look at the trace from 10 to 8, where previously we were going 2, 3, 13, 12, 11, and then the destination. Same case here. Okay, and actually let me make sure that that is actually getting updated. Let's say on XR1, clear, BGP, VPN v4, unicast star, soft out. Okay, and in. Okay, let's also say then on, was that on router 10? We do the trace. So in this case, it didn't have an inefficiency in the data plane. Basically, forwarding is not supported. And this was the problem that I had ran into before, that there's a caveat with iOS XR, and as far as I know, it's not documented this way, that it is a problem. But if we go to the iOS XR documentation and look at the specific section under Inter-AS L3VPN, so this is under the iOS XR config guides, down under release 5.2 for routing, then, or actually no, not routing, L3VPN. L3VPN, implementing MPLS layer 3 VPN, and then this is going to be providing connectivity across multiple autonomous systems with MPLS VPN inter-AS with ASBRs exchanging VPN IPv4 addresses, or in other words, this is option C. And we want the configuring, well, let's just look at the whatever's under there, which is we need to see where is the peering that goes to the reflector, which is, okay, it says don't forget to put a static route, so we had already done that on the ASBR. And then we need to say, okay, we're not in a confederation. It should say that this is related to peering to the reflector. Configuring the route reflectors to exchange VPN IPv4 routes, which is next up unchanged. So I think what the issue is that it's simply a required config that you put that in. If iOS XR does not have this under address from a VPNv4, when it's an eBGP VPNv4 session, the data plane is simply broken. And the reason why is that it's using the wrong label as the transport to the remote next hop. So if we look at XR1 and we look at the show BGP VPNv4 unicast for let's just say all. And if we look at the destination in this case is what? The destination would be like 7777. So if we show unicast for the route distinguisher 100:100, prefix is 7777/32, it says the next hop is 3333. So we look in the global table, how do we get to 3333? We have an ISIS route to them. If we look at the show MPLS forwarding table, it says to get to 3333, we're popping the topmost label and then sending the traffic to XR2. But the issue is that from XR2, it doesn't have the VPNv4 label in order to figure out how are we actually going to route the traffic. So technically, we could make XR2 in the transit path by giving it the VPNv4 label, but otherwise it's going to be sent with only a one-hop label in the stack, and ultimately end result here is that traffic is broken. So if we look at the change here, when we say roll back the config last one change, so now we are saying next hop unchanged, and when we show empty this forwarding table, the difference is now the next hops do have labels, which are the ones that are in the remote destination, remote ASs. So if we trace to 3333, source this from our own loopback 11.11.11.11, the key is that it has to be using an LSP end-to-end. Okay, we're the same to router 2. But again, with an intra-AS design, normally this is solved very simply by running IGP plus LDP. So you enable OSPF everywhere and you turn on LDP autoconfig, or you enable ISIS everywhere and you turn on LDP autoconfig. So then there's always a one-to-one binding between the IP routes and the labels. But in this case, we need to take it a step further, which is to advertise the routes into BGP, include a label with them, and then redistribute the route from BGP back into IGP. That's where we do the conversion between the LDP label and the BGP label. So if we look at on router 3, and we look at the show IP BGP labels, this is one of the other verifications that you want to look at. that for the route to the remote AS, there has to be an out label that is learned through BGP. Same should be true on XR3. If we show BGP IPv4 unicast labels, the remote destination is 2222 and 3333. The received label, which is the one that the other end is allocated, that's the one that is coming from BGP IPv4 plus label. So like on router 3, if we say show IPBGP for 2222, it says in label is 17. This is the one that router 3 is allocating. If we look at 11, 11, 11, 11, the out label should be what XR3 is allocating. Okay, questions up to this point on the inter-AS option C example. So the key points again were that we need to establish the transport for the VPN v4 session that was between router 1 and XR1. So we had to redistribute IGP into BGP or use the network statement, advertise the route with an IPv4 plus BGP label. So that means we need to send label on iOS. On iOS XR, we need to enable the address family IPv4 labeled unicast, allocate the labels under the IPv4 unicast address family, and then redistribute from BGP back into IGP. That was doing the connection between BGP label and IGP label. Then on the route reflectors for VPN v4, we need to say next hop unchanged, which means that you're going to use the original provider edge router that is allocating the VPN v4 route as the endpoint of the VPN v4 tunnel.